All right, so here's the test review for units 3 and 4. I'm going to go through some parts a little bit quicker and some parts I'll take a little bit more time on. So first one is, it says you need to be able to solve a system of equations in two variables involving linear equations. So there's 3 different ways that you can do that. I'm going to show you all 3 on this same equation just so you're going to see that either way that you do it, you're going to get the right answer. So the first way is substitution. If you're going to substitute, you're going to want to solve for the variable that doesn't have a coefficient. So in this case, we're going to solve for y, all right, because that one doesn't have a coefficient. So when I solve for y, this equation is going to be y equals negative 2x plus 6. So we move that 2x to the other side. Now, this whole new equation is going to get plugged in for y in our first equation. All right, so it's going to look like 3x minus 3, and then we're inputting negative 2x plus 6 is all equal to 9. So, just so you can see all of that. Okay, so then you're just going to simplify and solve for x. So we're going to distribute this negative 3 to everything that's behind it. So we're going to have a positive 6x minus 18 is equal to 9. We can combine like terms and move that 18 to the other side. So this is going to become 9x, and then when I add 18 to this other side, that's going to become 27. Then I'm going to divide by 9, and it's going to give me that x is equal to 3. That's the first part of our solution. And then we're going to take that and we're going to plug it into this equation where we solve for y, because then we're just going to be simplifying. So we know that y is equal to negative 2 times 3 plus 6. So this is going to give us that y is equal to negative 6 plus 6, so y must equal 0. Make sure that if it asks you to put it as an ordered pair, you're always writing x then y. So this is 3, 0. That's our solution to that first one. Okay, now if you want to come over and you want to do it using elimination, remember elimination means we're trying to eliminate one variable, so x or y. So you're going to do that by creating that additive inverse. So if you look, you have 3 and 2. Those aren't going to cancel each other out if I add these two together. Negative 3 and 1, those aren't going to cancel each other out either. But if I multiply this whole bottom one by 3, that's going to give me 6x positive 3y and 18. Now we'll be able to eliminate our y's because we've created that additive inverse, that plus 3 and minus 3. So if we add up these, this is going to cancel, and I'm going to get that 9x is equal to 27. I'm going to divide by 9, x is going to be equal to 3. Now, you can take that, and remember, you can plug it into whatever equation you want to plug it into, the first one or the second one. So in this case, I'm going to plug into the second one just because that y doesn't have a coefficient in the second one. So I'm going to plug in 2 times 3 plus y is equal to 6. So that's 6 plus y is equal to 6. Obviously, if I subtract 6 on both sides, that's going to give me that y is equal to 0. Okay, so again, same answer no matter how we did it. So that's going to go ahead and give us our ordered pair of 3, 0. All right, last one is Gaussian elimination. Remember, to do Gaussian elimination, the first thing that you need to do is you need to write it out as a matrix. So if we were going to write this out as a matrix, we would write 3, negative 3, 9, 2, 1, 6. You can draw that dashed or solid line that separates right here for equals, or you can leave it out. I like to leave it out when I'm solving just because then I don't confuse myself thinking it's a 1 or something like that. So remember here, ultimately your goal is to cancel out any of these 4 numbers. If you can get any of these 4 numbers to equal 0, then that's going to work. I always pick the bottom left one because when you get to doing 3x3s, you have to create that triangle at the bottom. And so it kind of just gets you in that habit. So if I wanted to zero this out and I have to use this one, all right, adding these together right now is not going to do it. But if I say that I wanted to do something like 2R1, so that would bring this up to 6 minus 3R2, that would subtract 6. That would zero this out to create our new R2. Okay, so what that would look like would be 6, -6, and then positive 18. So that's me multiplying 2 across this top row, minus, and then I'm going to multiply all these by 3. So 6, 3, and 18 also. So if I go ahead and subtract, this is going to zero out. Then I'm going to have -6 minus another 3 is going to give me -9. 18 minus 18 is going to give me 0. It's fine that we got 0 in 2 places. We were really only trying to get this one to be a 0. So now we can rewrite. And this row stayed the same. We didn't mess with that row at all. So that one stays the same. This becomes our new R2. So 0, -9, 0. Once I've zeroed out one of these 4 terms, I'm done with 2x2s. I'm going to rewrite it as an equation, and then I'm going to solve. So I'm going to have 3x minus 3y equals 9. Again, that equation did not change, but this bottom one has become -9y is equal to 0. So we're going to do back substitution. So you start at the bottom and you work your way up. So obviously, if I divide by -9 here, this is still just going to give me that y is equal to 0. That's good. And then if I take that and I plug it into this equation right here, I have 3x minus 3 times 0 is equal to 9. So I basically have just 3x is equal to 9, so x is equal to 3. Again, write it as an ordered pair, 3, 0. So it shows you that no matter how you decide to do it, whatever your heart desires, that's going to work. I'm going to show you on the calculator real quick just so you guys can see. So if you're on the calculator, you're going to go to that calculate section. And you always have to start with the row operation. So in this case, I'm trying to reduce a matrix. So I need to start menu, and then 7 is matrix, and it comes up with all the different things it can do. You need menu 7-5, reduced row echelon form, not just this one, all the way reduced. So menu 7-5, and it's going to give you this RREF. Then however you like to put in the matrix. I know some of you guys like to hit this button here. I always go back to here just because I've gotten in the habit of that. In this case, if you look at your matrix, you had 2 rows, all right, but you had 3 columns. So we're going to keep that 2 rows, tab, 3 columns, enter, and we're going to get this. We're going to type in our matrix, so 3, -3, 9, 2, 1, and 6. Then we're going to go ahead and just hit enter. It's going to reduce. And again, this is telling you that 1x is equal to 3, 1y is equal to 0. So 3, 0, that's what we've gotten every single time. All right, so that's 2x2. And then we're going to keep going on this first page, and we're going to go to solving system of equations with 2 variables. That is a linear and a quadratic. So when you guys do this one, you can do it however you want to do it. But in this case, you can't use Gaussian elimination because you have x squareds and x's. So you can't create like an x column, a y column, and a solutions column. So I'm going to show you a substitution first, and then I'm going to go ahead and I'm going to show you with elimination. So substitution, you're going to go ahead and again solve for a variable that does not have any type of coefficient with it. So if I solved for this y, I would get that y is equal to x squared minus 4. And then I would take this whole entire thing and I'd plug it in for y in my other equation. So that's going to give me -2x plus x squared minus 4 is equal to -1. In order for you guys to solve these, you have to be able to factor. If you guys do not remember how to factor, you need to watch some video on factoring so that you can do it for this one problem if it comes up. All right, so if you're going to factor, you need to write it in degree order. So that's starting with squareds, x's, and constants, and all your constants have to be on the same side. So we're going to rewrite this as x squared minus 2x. Move this -1 over, minus 3 is equal to 0. Now you can go through and you can factor. So when you factor, there's a lot of different ways to factor, okay? So factoring is actually our next unit. So we'll talk about a lot of different ways to factor in our next unit. I think the easiest way is if you want to do what's called the X method with grouping. So if you have this leading coefficient that's a 1, which is good, that's what you want, you're going to create this little X down here at the bottom, or wherever you want to create it. The top of your X is going to be A times C, the bottom is B. So A times C, your A value is 1 because you don't have a coefficient in front of the X squared. Your C value is -3. 1 times -3 is -3. And your B value is the coefficient in front of your X. So in this case, it's going to be -2. Okay, you are trying to find numbers that multiply to give you the top. So multiply to give you -3, but add to give you -2. So if you look at what your factors of 3 are, there's only 1 and 3. If I want it to add to give me -2, that means that this 3 is going to have to be the -1. So that means my factors are 1 and -3. Now, anytime that your leading coefficient is a 1, so look right here, see how there's nothing here? That's like there's a 1 there, okay? Anytime that that happens, these factors that you just got, those are the factors and those are the answer to your problem. So you can rewrite this whole trinomial as x plus 1, x minus 3. Okay, so you just took those factors, x plus 1, it was +1, x minus 3, it was -3. This is still equal to 0, and now you just set them up separately and solve. So you're going to have x plus 1 is equal to 0, and you're going to have x minus 3 is equal to 0. If you subtract 1 here, it's going to give you that x is equal to -1. If you add 3, it's going to give you that x is equal to +3. Then you're going to take both of those and you're going to plug them into this equation right here and see what you get. So if I take 3 and plug it into here, I'm getting 3 squared, which is 9, minus 4 is going to give me that y is equal to 5. If I plug in -1 to here, -1 squared is 1, minus 4 is going to give me that y is equal to -3. So on these, you're going to have 2 answers. So my answers are going to be -1, -3. And my answer is going to be 3, 5. Okay. All right. I'm going to show you again, same one, but we're going to do it with elimination instead of substitution. So when you're trying to do elimination, all right, you can only eliminate if they're exactly the same variable. So x's I can't eliminate because I have a squared and I have just an x. So the only thing that I can eliminate here is a y. So I have positive y, positive y. If I take this whole top and I just multiply it by -1, I'm going to get positive x squared, I'm going to get negative y, and I'm going to get +4. And then I still have this -2x, positive y, -1. Now when I go to eliminate, my y's are going to eliminate. These two cannot combine because these two right here are not the same thing. So you're just going to rewrite it as x squared minus 2x is equal to 3. Again, if you're going to factor, this 3 needs to be on this side. So it's going to be x squared minus 2x minus 3 is equal to 0. And then as you can see, we get the same trinomial here and here. You would factor it the exact same way. You'd get the exact same answers. All right, so your answers to this one would still be -1, -3, and 3, 5. If you guys are given this on the calculator section, all right, you can put these in y equals form and then you can graph them and just see where those two things intersect. So if I was going to do that here, okay, I'm going to come down and I'm going to go to graph. And if I solved this first one for y, which I did already, I get x squared minus 4. Okay, enter. I get that parabola. and then tab so I can type in another one. If I'm going to solve this one for y, I need to move that 2x to the other side. So it's going to be positive 2x minus 1, enter. And you can see that it hits two separate spots. Those two spots that it hits, those are your two answers. So if you go to menu and then analyze graph, which is 6, it can tell you all these different things. So you can go and find what the intersection is. And so lower bound just means go to the left of it. Upper bound, so you're going to highlight it. And as you can see, -1, -3, that's one of my answers. Okay, awesome. So then I can go back again. Menu, analyze graph is 6. Intersection is 4. So now I can go over here and I can highlight this one and it tells me 3, 5. So if you're given it on the calculator section, you're more than welcome to do it that way. You can do that with the linear ones above too. So they're just going to intersect in one spot, obviously, other than 2. All right, so that's the first couple things. If you need help with anything else in the review, make sure you hop on to see those other videos. All right, bye.